Welcome back, STEM students, to Mampaisan's online classroom. For today, we're going to discuss another topic which is divided into three parts. This one will be about kinematics quantities. These topics are all under Module 3, Kinematics Motion Along Straight Line. Let's start with identifying the objectives. Our objectives are to define motion and the quantities used to describe it, to differentiate distance from displacement and speed from velocity, and lastly, to solve word problems about distance, displacement, speed, velocity, and acceleration. As an overview, this is going to be the outline of our discussion. Number one, we're going to discuss motion as it is being defined and described. And then we're going to have the kinematics related quantities, which are distance and displacement, speed, velocity, and lastly, acceleration. Let's start with describing and defining motion. First, let's discuss the branch of physics that deals with everything to do with motion. In our introductory lesson, we have defined that there are two basic branches of physics or major branches of physics, the classical and the modern. Then under classical, we have classical mechanics, optics, electromagnetism, thermodynamics, waves, and acoustics, diba? So, from here forward, when we say mechanics, that pertains to classical mechanics as well. Kasi diba may quantum mechanics, may, there are also relativistic mechanics. So this time, uh, let's just remove the classical and assume that whenever the word mechanics is mentioned in this lesson, it pertains to classical mechanics. Okay, mechanics can further be subdivided into two branches, kinematics and dynamics. Again, let's recall mechanics is basically the branch of physics that deals with studying motion and not just motion but the cause of motion, which is force. Now, what's the difference between kinematics and dynamics? When it's kinematics, the aim is to describe motion quantitatively, meaning aside instead of saying that something is moving fast, we associate the fastness of an object with a numerical value. How fast? What's the speed? Instead of saying the location or nearness of an object, or instead of saying the store is nearby, we associate a certain number to that nearby. Uh, it could be 5 meters away from your house, or it could be 10 meters away from your house, and stuff like that. So that's the purpose of kinematics, basically to describe, okay? But on the other hand, dynamics is the branch of mechanics that deals with knowing how motion happens and what are the concepts behind the behavior in the motion of objects as we observe them. Bakit humihinto? Why is it moving faster? What makes it move slower? Okay, those are the things that we could answer using dynamics. But in this lesson, again, we're going to focus on kinematics. And mechanics, we study mechanics because basically we need to analyze specific phenomenon related to motion, just like the motion of skydivers. Kasi without knowing the technicalities and concepts behind the motion of skydivers, safety precautions will not be effective. So for safety precautions and other precautions pa, other um, manufacturing of materials, we should consider describing motion as well as knowing the factors that will affect your motion. So, yung purpose why we study mechanics, okay? May purpose siya, hindi lang siya to make your life miserable like that, okay? So let's define motion. Basically, motion is the motion of an object, movement rather of an object, which results to its change in position. Observably, you will know that an object moved if originally it is placed at a specific point in uh, in your house, for example, and then it moved to another place. So, paano mo malalaman na nag-move yung kawali? If from the container or the cabinet, it moved towards the stove. There is motion, di ba? Or for example, the spoon. You know that the spoon is moving when you eat because from the plate, it moves towards your mouth. Nagbabago siya ng position. Okay? And then quantitatively, we describe motion using the following. Number one, in terms of its position, okay? Which can either be distance or displacement. We could also describe motion using the rate of change in position, which can either be speed or velocity. And then we could also describe motion using the rate of change in position over time or the acceleration. This is the part one, which is kinematics related quantities that will tell us the difference and similarities between distance and displacement. Let's start with distance. When we say distance, that's basically the total path length traveled by an object. It is the length between an identified reference point and a designated position, meaning when we say reference point, that's the original position, and then the designated position is the destination. Distance is a scalar quantity, meaning we just express it using numerical value or magnitude. And then the possible units are kilometers, feet, miles, or any unit of length. Pwedeng yard, inches, centimeters, millimeters, etc. But we have a standard unit which is meter. Let's have an illustration for this. Let's say that we have this boy who came from the reference point, which is the tower. And then after traveling for 10 meters, he reached the identified position or his destination. Here, obviously, the distance traveled by the boy is 10 meters. Now, how about if your movement is not just one directional or you're not moving throughout one directions only, katulad ng boy kanina. Let's say that you want to go to the church from your house. And of course, from your house towards the church, it's not always a straight path, no? Unless kapitbahay mo ang church. So let's say that from your house, you have to walk 1 meters, 1 meter rather, 1 meters, 1 meter across a street. Ayan, may street kunyari sa bahay niyo. Tapos liliko ka on a street that has a length of 0.5 meters and then you still have to uh, go to another direction which has a length of 2 meters, so that's another street, and then you have to go to another street which is 1.5 meters. To get the total distance that you traveled, you just need to add together this, the 1, the 0.5, 2, and the 1.5. Therefore, the distance would be 5 meters. So in solving distance, you just have to add all the magnitudes because we do not consider the signs here. Mag-add ka lang ng mag-add. Now, how about displacement? Displacement is distance with direction, meaning it's a vector quantity which has distance as its magnitude. As a definition, it is the measure of how far an object has moved in a particular direction from its original position. If distance is just telling you how far an object has moved, or the total path that the object moved through, the displacement has direction, not just how far, but also in what direction. This is usually described as the length between the initial position and the final position, or the change in position including the sign of change. It's the change in position, and remember, we are already considering the sign because this is a vector quantity. And remember, when we talk about vector quantity, the signs or the positive and the negative denotes direction. Since displacement is a vector quantity, it has magnitude and direction. And again, if you remove the direction of the quantity or of displacement, we will be left with distance. Therefore, again, displacement is just distance with direction or distance traveled from or distance between not traveled distance between an original position and a final position. It is usually given as a symbol, lowercase letter d, that is in boldface because ano nga siya, vector nga siya, which is a symbol for vector quantity. So ulitin ko lang, remind ko lang kayo, no? If you're going to write down vectors, this letter D or displacement could be written as D with half an arrow on top or a D with a full arrow on top para hindi ka na magbo-bold face. So kapag gumamit ka na ng arrow, you don't need to bolden the letter. It has the possible units, the same as distance, as well as the standard unit. Dun sila nagkapareho, no? So, distance and displacement, both of them describes position. They're different. Both of them describes position again. And then, they have the same possible units as well as the same standard unit. However, they differ because displacement has direction. Here's an illustration. We again have the boy, and then the boy came from point A, the tower, and then he went towards point B uh, at a specific direction. So in this case, both distance and displacement are present, of course, because the boy changed its position or the boy moved, di ba? For the distance, it's 10 meters. Ay, ito pala, baliktad. Ito, this one. It's 10 meters. And then for the displacement, it's 10 meters west. Now, as you may notice, the distance has the same magnitude as the displacement. This only happens if the object we are talking about is going or moving at one direction only, just like here. The boy did not change direction. He just went westward. Wala na siyang ibang pinuntahan. Now, how about if the object changed direction, specifically, it went back or the boy went back towards point A, the tower, where he came from originally? What would happen to the distance and the displacement? Oh, so nandito pumunta siya indicated by the red arrow, and then he went back indicated by the blue arrow. The displacement is 0 because we define displacement as the length between the initial and final position. Now, since this point A is the original position of the boy, tapos bumalik siya, it means that the final position is also this one, point A. What's the length between point A and point A? Diba wala? That's 0. That's why we have displacement equal to 0. Now, how about the distance? For the distance, we compute all the paths taken by the boy. So that's 10 meters westward, and then dahil bumalik siya, you add another 10 meters. Therefore, the total distance traveled, ayan, hindi naka-bold face yan, tsaka walang arrow ha, kapag distance. The total distance traveled is 10 meters. We can also mathematically show how the displacement became 0. Displacement is also known as the difference between two distances or the change in position. No? So remember in mathematics or in sciences, the Greek letter delta denotes change or difference. Okay? So, syempre, a difference, that's D1 or initial position, initial distance minus final position or final distance. Anong bang unang distance na na-travel ni Boy? Di ba 10 meters going to the west? So 10 meters yun, initial. Tapos final niya, 10 meters pa rin kasi bumalik siya. When you subtract 10 from 10, obviously the answer is 0. Okay, let's have to check your understanding. Number 1, here's the question. The following points in the line are equally separated from each other. Which of the following paths taken has the greatest distance? Let's count for each anong tawag dyan, option. For letter A, we have B to D. So before you arrive at D, you have to pass through C. So that's 1 unit and then 2 units. Okay? From A to D naman, that's going to be from A to B, B to C, and then C to D, that's 3 units. And then letter C, that's from A to C. So that's A to B to C. And then you go back to C. If you count all the units, that's going to be 3 units. And then the last one, you're from C, you go to E, and then you go back to B, and then you go back to C. If you count all together the units, that's 6 units. Therefore, the one that gives us the greatest distance is letter D. Okay, so that's for number 1. How about we have the same scenario, but this time, which one has the greatest displacement? Again, let's look at the points. The letter A, that's B to D, that's 2 units. And then letter B from A to D, 1, 2, 3, that's 3 units. And then letter C, if you're going to look at letter C, pumunta pa siya ng ano, galing siyang A and then it went to C. So parang nag-stop over pa siya sa C and then it went back to B. In this case, since we are talking about displacement, we just have to consider the first point or the original position and the final position. You disregard things that come in between. So if we have A and B, that's just 1 unit. And then as you will notice in letter D, ang dami niyang pinuntahan, no? But again, we're just going to look at the first position and the final position. And since the first position and the final position are the same, that's at point C, the displacement is 0. So the answer for this, the one with greatest displacement is letter B. Okay? Diba, ang dali lang. Now, let's put some numbers on them. Let's say that Billy walks 5 meters to the east, then walks 3 meters to the west. Question, what is his distance? As you may notice, the given are vectors, 5 meters east and 3 meters west. So these are displacement. How will you be able to get distance when the problem gives you displacement? Simple lang, you remember that displacement is distance with direction. Therefore, again, the magnitude of displacement is considered to be distance. In this case, since you have to solve or get the distance, you disregard the directions and you just add together the magnitudes. Yan, the magnitudes, which gives you 8 meters kasi that's 5 plus 3 meters. Ganun lang siya. Now, how about same scenario ulit? It's Billy, same displacements, but this time you are asked to get a particular total displacement. Okay? So in this case, we're going to add the given the way we add vectors. Remember, when we have two vectors that are in opposite directions, we have east and west. First, we subtract the magnitude. So that's 5 minus 3, 2. A to C, puro 2 yung numbers. So how do we distinguish naman the direction, no? To get the direction, we copy the direction of the vector with higher magnitude. Since 5 is obviously greater than 3, we copy the direction of 5, that is east. That's why our answer is letter B. Thank you for listening. That's part 1 of kinematics quantities or kinematics related quantities. See you again for kinematics related quantities part 2.